The following video will be about the 8th grade can challenge and Justin Blueber by Tyler Racklin and Justin Brown. The goal of the 8th grade can challenge is to apply our knowledge of energy transfer to evaluate different insulation materials and structures in order to design and construct an insulator for a standard 355 milliliter soda can filled with hot water. The first thing we had to do was do research so we could start gathering materials. The first useful material we found was poster board. Poster board would serve as the backbone of our insulator and give it a solid shape. The next material we used was the reflective emergency blanket. This would be the most abundant material in our insulator. The next material we used was a roll of heat-resistant tape. This tape was used to stick things together as well as wrapped around our insulator to prevent heat transfer. In the process of bringing the insulator home, the heat-resistant tape was lost. Scotch tape was used as a replacement. The last material we used was a handful of styrofoam peanuts. These were put in the bottom of the insulator to further insulate it. Then began the construction process. The first step of our construction was to cut 4 pieces of poster board and glue them together to make a rectangular prism. We had to remind ourselves that our insulator had to fit inside Mrs. Power's magical measurement box, which was 10 centimeters by 10 centimeters by 20 centimeters. Next, we wrapped the entire outside of our insulator with emergency blanket and taped it down with the heat-resistant tape. Then we took the heat-resistant tape and wrapped the entire outside with it, from top to bottom. Next, we covered the inside walls of our insulator with emergency blanket and put styrofoam peanuts in the bottom. To plug the hole in the top of our insulator, we measured and cut 2 cardboard squares, put one on top of the other, covered them in emergency blanket, and then covered the top with the heat-resistant tape. Because the can had to slide easily in and out of our insulator, to get the right shape, I took a can and wrapped it in emergency blanket, taped it down, and then put that shape inside the insulator. Our insulator was complete. All that was left to be done was poke a hole in the top and test it. To test our insulators, our science teacher put warm water in a can, about 68 degrees Fahrenheit, put the can in our insulator, and put a thermometer in the can. We had to poke a hole in the top of our insulator to stick the thermometer in the can through our insulator. Then our insulator was put in freezing water and left there for 20 minutes. After testing and receiving our data, we discovered that our insulator had beaten everyone we tested against. However, the leader of the class had beaten us by 0.1 of a Celsius degree. 0.1. Heat is transferred from one material to another by conduction, convection, or radiation. Insulators are used to minimize that transfer of heat energy. In this experiment, we were dealing with conduction. In conduction, heat flows throughout the medium because the atoms and molecules in the medium are in contact with each other. Heat, or thermal agitation, of the medium's atoms and molecules is passed along from the warmer parts toward the cooler areas by a relay process, where an agitation of one atom or molecule is passed along to its neighboring atom or molecule. To slow down the transfer of heat by conduction from one solid to another, materials that are poor conductors are placed in between the solids. The materials we chose, including the styrofoam peanuts and the emergency blanket, were poor conductors. This means that their molecules did not move as quickly even though their neighbors were moving very quickly. This allowed for less heat transfer and allowed our insulator to better insulate the heated water inside the insulator. The 8th grade can challenge went successfully for the entire grade, even though we lost by 0.1 of an infuriating degree. Thank you for watching this video, and hopefully you will participate in your own can challenge someday and won't lose by 0.1 of a degree.